Hello, and thank you for joining this session today. My name is Clarisa Gonzalez Chavez, and I will talk to you about digital technologies in sustainable production systems, Part 2. By now, we should have understood that Industry 4.0 does not impact only the technology available inside manufacturing plants. It promotes the restructuration of industry as a whole. It is identified as a new organization with a steering approach for the entire value creation chain over products' life cycles and hopefully after the end of the life of products. This industrial paradigm relies on 4 pillars. Industrial integration over the value chain. This means that the acquisition of a business operating at the same level of the value chain in the same industry is done. Also, seamless engineering over the entire life cycle. Then, vertical integration and networking of the production systems, a strategy whereby a company owns or controls its suppliers, distributors, or retail locations to control its value or supply chain. Vertical integration benefits companies by allowing them to control processes, reduce costs, and improve efficiencies. Also, continuous development of underlying and connective technologies. Now we have discussed the organizational implications of Industry 4.0. However, remembering one of the many definitions of Industry 4.0, we need to highlight that there must be a smart integration of product and processes that add value at an industrial level. Therefore, there are 9 technological pillars: autonomous robots, simulation, organizational and vertical integration systems, industrial Internet of Things, cybersecurity, the cloud, additive manufacturing, augmented reality, and big data and analytics. All the mentioned technologies have an important role in the future of production, as we need to develop technologies that support higher production scalability that integrates and makes use of real-time data, intuitive human-machine interfaces that facilitate virtual production, and flexible automation that allows taking advantage of the many processes of automation technologies while keeping human support in the room. The digital transformation, the migration from non-digital operations to an adoption of innovative digital technologies at production and management level relies on 4 pillars. Digital data that has the capacity of gathering, managing, and analyzing the data at hand. Automation to provide cognitive products and environment able to work autonomously and organize themselves. Connectivity to synchronize supply chains and shorten innovation cycles. And digital customer access for more transparency and new service development that are fit to cover customer needs and requirement providing value in a sustainable manner. It is important to highlight that digitalization poses requirements on companies, which need to be addressed to successfully and smoothly migrate towards the industry of the future. These include: understand that the digital transformation is a process and not a goal. It requires constant efforts from the organizations around it. Leadership skills are one of the main requirements for digitalization. Also, a disruption culture that adapts to change and stays open-minded and flexible. Openness, transparency, and accountability. Data and insights that actually capture experience and customer feedback. And last but not least, technical skills, which are mandatory to achieve a smooth digitalization process. So now, what does that mean for sustainable production? Beginning with a definition, sustainable production is a development of the manufacturing industry ability to underpin society's needs, meaning that the goal is not only to create wealth, but to do it in a way that will support sustainable economic development, meaning that it should consider the triple bottom line, or in other words, the 3 Ps: people, planet, and profit. Keeping this in mind is of high relevance, as today, present industrial systems are not sustainable in the long term, because of the demands upon the world's natural resources. We cannot continue with a linear economy where we only think of taking resources, making products, to then dispose them. In the 1990s, manufacturing was driven by four main drivers: flexibility, time, cost, and quality. Today, sustainability comes to replace the main concern, where although it is important for companies to be economically sustainable, they are able to make informed decisions and assess trade-offs that prioritize social and environmental sustainability by inviting them to the discussion. The life cycle stages of a product are typically divided into three main stages: beginning of life, which covers design, testing, and production; the middle of life, which covers product usage and services; and the end of life, which covers recycling, refurbishing, or disposal. Today, with the tools that we have available through digitalization, we can promote a more open communication loop between different life cycle stages that allow continuous improvement, informed decisions, and better information and material flows for a more sustainable economy. The discussion we've been sharing could lead to bi-directional digitalization, which has been suggested by some authors and researchers to digitalize the entire development life cycle, including the use and service phase of a product. This would have the advantages of support the global optimization of all the phases within the life cycle, target added value and cost reduction for customers, have more efficient integration of new technologies, management of quality, legislation, and emission targets, facilitated by data visibility. The image here tries to exemplify how communication, information, data, and material loops could look like. This could lead to increased flexibility of production systems, required to achieve higher individualization, faster and more effective responses, self-adjusting products, and product improvement cycles. The final target of a product and production optimization is higher and impacts cost, quality, and scalability. So, to conclude, what do you see as new in production environments? Industry 4.0 requires still raw material, energy, and information, and through the use of underpinning technologies, which are unavoidably controlled by the capabilities of the system, are able to produce digital and more innovative products to satisfy customers' needs. The image to the left roughly summarizes some of the technologies that we have identified as most relevant in this fourth industrial revolution: big data and analytics, cloud computing, cybersecurity, horizontal and vertical integration, robotics, augmented reality, additive manufacturing, simulation, and Internet of Things. Thank you very much.